Just kind of rehashing what we've already talked about. Compound interest is the idea that I want the money that I have earned, that my initial principal has earned, I want that money eventually to also earn money. Okay, so if I put in, let's say, $100 into some account that has let's say, a 5% interest rate, and interest rates are provided as annual interest rates. So let's say that I get that 5% to accrue completely. I got to let it sit in there for an entire year. Let's say that after 1 year, I should have $105 in there, right? Okay, 5% of 100 is $5, and then I add that to my account. So I have now $105. The hope with compounding, okay, the purpose of compounding, is that in year 2, when I don't withdraw any money, that in year 2, the $105 now is the principal that earns interest. Does that make sense? So my $5 that I earned in year 1 will help me earn more money in year 2. Okay? There are some accounts that doesn't happen. There are some accounts that do not compound, and the $100 that you put in, the principal that you put in, is the only thing that earns you money. So in year 2, if I had no compounds, in year 2, it would say that my principal is going to default back to the original $100 that I put in. And then I earn $5 more off of that, and now at the end of year 2, I have $10. And then in year 3, I default back to my original principal of $100, and I earn $5 off that, and in year 3, I have $115 total, right? Okay. The idea of compounds is that after year 1, the interest made gains interest in year 2. Okay, so in year 2, when I start year 2, 105 is my new principal. Okay, and maybe that gets me, what's 105? Let's see here, we'll just compound once a year. So let's 105 times 0.05. Okay, add that to $105. So in year 2, then, when I start year, I guess I should be starting year 3, my new principal is the 110.25. Does that make sense to everybody? Okay. So we want our money earned to eventually earn us more money. Okay. And that's what this compound interest formula is going to do for us. Okay. Now you guys know what simple interest is. Simple interest is the idea that there are no compounds. Okay. So interest earned is your principal times your rate times your time. So let's leave time to be 1 year. We were doing simple interest when I said $100 times 0.05 gives me $5, right? So that capital I, interest made, would be $5. I then add that back to my principal, and I have $105 now in my account. Using that formula, eventually, with a little bit of factoring, and that process right there, develops our formula for compound interest. Okay, now you don't have to write any of that stuff down right now, and I'm not going to go through it just for the sake of time with you right now. But there is a video. I put a video together over the weekend, posted online, that shows you the creation, the proof, the derivation, whatever we'll call it, of that formula. Okay, and if you can factor, you should be able to come up with that formula as well. It's really not that difficult to deal with. The R over N thing is something that people struggle with. The R over N is simply, if I have 5% interest rate and I'm going to compound this twice a year, okay, then this 5%, after 6 months, that whole 5% doesn't get applied to my principal. Does that make sense? Only half of that 5% should be applied to my principal because it hasn't been in there for the entire year. Does that make sense, everybody? All right, so you have to take your interest rate and just basically divide it by how many times you compound. So if I have 5% and I'm going to compound it, let's just say 5 times in a year, then at every compound, I'm only getting 1% back from that principal. Okay? And then the n to the t, or sorry, not n to the t, the n times t, the exponent there, that is just telling me how many total compounds have occurred during the duration that my account has been active. Okay? N being the number of compounds, T being the number of times, number of years that you're putting that money into the account. Okay. Now, what we need to understand is when we do these problems, parentheses matter, exponents matter. Okay, so we got to be careful with our calculator. But at the same time, a lot of the questions are going to be kind of multi-step questions, where they ask you, here's $1,000 invested annual interest rate of 4%, compounded quarterly, find the total amount after 10 years. Okay, and the idea is that you just leave there, you don't withdraw anything. But they might then, that might be like question A. Question B might say, okay, what if we compound it monthly? That's question B. And then question C is, okay, let's compound it daily. Okay? And then they ask you to kind of look and compare which compound is better. Okay? I'm just going to give you the kind of the default answer to that. If everything is the same, if principal, interest rate, and time is all consistent, then obviously the more compounds that you get will yield the larger value, because what's that larger compound going to do? It's going to make this exponent bigger, right? The larger the exponent, the quicker something grows, correct? Okay. So if we can keep everything constant but provide more compounds, we will get more money in return. Okay. So let's just do a problem here, and we'll talk about the results that we get from that, and how then they can change some of these problems to maybe make us think a little bit more. But this is just a simple, and I think in your first assignment 4.1, you see a couple of these, very simple. They're saying A of t is equal to P 1 plus R over N raised to the NT, and it's just plugging in values. We've got $1,000. My interest rate is 0.04. When people mess these up, that's the biggest mistake I see. They just put 4, okay, which would make this a 400% interest rate, which would be awesome. Then N, okay, N is the number of times that you're going to compound it. So quarterly means it's going to happen 4 times, right, in a year. And then we're going to raise that to the N times T. Now, this is just the way I type it in. I let N be 4, and then I will actually write multiplies by T. Because of how they stagger the questions on our TI-83 or 84, it's going to be a little bit easier to come up with answers for like parts B, C, and D with these things when they change the number of compounds if I type it that way. And I'll explain that here in a moment. But now it's just a matter of plugging that in your calculator correctly. Okay? So we're going to go and type in 1,000, parenthesis, 1 plus 0.04 divided by 4. Okay? Now I don't need any additional parentheses around the 0.04 divided by 4. It's not wrong to put them in. I usually do put them in. The order of operations says that it's going to do multiplication and division before it does adding and subtracting, right? So it'll do what we want to do. It'll do 0.04 divided by 4, and then I'll add that to 1. Okay? So that's fine. We're then going to raise that to the N times T. This is where I don't change it. In our problem, it would be 40, right? Okay? I just leave it as 4 times 10, and I'll explain why here in a moment. But if I hit enter, I'll get $1,488.86. So that tells me that if I leave my money in this account for 10 years and I don't touch it, that's the amount of money that I have earned off of that money, okay, off of that original $1,000. Which is it's kind of how people sit money in accounts for retirement. They sit money in accounts for big purchases at some point in their life. And a lot of times when you maybe invest in an account, maybe you go take a Roth IRA for retirement or something like that. There are penalties that you are forced to pay if you pull that money out early. Okay, so in an IRA, they might say you have to leave this money in there for 20 years before you can withdraw it. But if you do withdraw it before that 20 years, you have to pay a percentage of taxes on that money when you withdraw. Does that make sense? Because what they were trying to do, and this is how like insurance works. This is how banks stay banks and they don't fold like they did in the Depression. Is that they take your money. Let's say I put $1,000 in it, and they basically have a contract with me that says you have $1,000 in here, and you can ultimately take that $1,000 out anytime you want to and use that $1,000. Okay. But what they're going to do is they're actually going to take your $1,000 and they're going to put it somewhere else. They're going to invest it. They're going to use it. Okay. And they're going to put it in an account, probably a stock. Okay. And when they invest that $1,000 starts growing, and the bank is then going to shave off those dividends and keep those dividends, and now the bank just made money off your money. Does that make sense? Okay. Now, going back to the Depression, when the stock market fell, the banks aren't making any money, right? Okay. And that scares people. So people start taking their money out of the bank. So many withdrawals occurred that then banks could not support themselves to withdraw or pay back everybody that's invested in the bank. Does that make sense, everybody? So let's say that every one of us puts $1,000 in, we start seeing the stock market fall, and before you could go withdraw your $1,000, I went and withdrew my $800,000. Okay? Can the bank now pay all of you back? No, because I have your money now, don't I? Does that make sense? Okay, so that's what happened during the Depression, and that's why people are interested in the stock market and they get scared when it falls. Because they're afraid of their money, because they know it's invested somewhere else, that their money's not going to be there when they go to withdraw it. Okay? But a lot of, like certain types of accounts might have a stipulation where you have to leave it in that account for X amount of years, or you pay some type of penalty. Okay? Because they're saying that if we're going to leave it in there for 10 years, you have guaranteed us 10 years of time to kind of make your money grow for ourselves, okay, and we can take those dividends in as the bank. Insurances do the same thing. If I pay $800 a month, or a year for house insurance, and my house burns down, my insurance company is going to give me $375,000 to rebuild a house, okay. Well, my $800 that I paid for 10 years is not going to come anywhere close to that $375,000. Does that make sense? They take my $800 that I pay a year and they invest it in the stock market. And then the dividends are what then the business or the insurance company keeps. And if we have huge populations of people all doing this, paying a premium, a house insurance premium, and they take all those monies and they invest those in the stock market, then when they have to pay out an insurance claim of $375,000, they can do that. Okay, it's one of the reasons why people are worried. I guess insurance people are worried about driverless cars. Okay? For instance, like Warren Buffett, I read an article. He's concerned. He's really worried for his businesses because he owns like it's like a overarching company that underneath it are other insurance companies. Like Geico is a company that's underneath. It's like Berkshire or something like that is the overarching company. But you guys know who Warren Buffett is, right? One of the most wealthiest persons in the world. He's really worried for his companies because, and his net worth ultimately, with driverless cars, because with driverless cars, they're trying to eliminate what? Accidents. Okay? Which if you eliminate accidents, you eliminate the need for insurance. Okay? So car insurance will be very minimal in the event that we have driverless cars, and that is going to then take money basically out of his pocket that he's able to invest in the stock market. Does that make sense? Okay, and he can't make those dividends anymore. And people that are in insurance are worried about that. Obviously, maybe for the wrong reasons. They want car wrecks, right? Okay. Now, they don't want to pay the claim. I guess they want the potential of car wrecks. They don't necessarily want the wreck because they have to pay the claim out, right? But they want the potential of that because people are worried about having to pay that out-of-pocket expense to fix their car. So they know that people are going to invest in insurance so that they don't have to pay out of pocket. So those are kind of things to think about as we're doing these problems, and that's kind of the stuff that I'm interested in us investigating and understanding as we do this math. Not so much can I type in my calculator and get a number, but what kind of in the background, what companies use this for, how you can use it as a consumer. In this case, we're getting that $1,488 back, okay, or ultimately a dividend of $488. So here's the thing then. The question B will be, well, what happens if you compound it quarterly? So let's try quarterly. So a second, enter, okay? And this is the reason I like to type it in this way, because in the event, and we're all going to use our calculators on this, so I have to hit second, enter, and it brings back up this line that I can edit, right? Okay, and I can change anything I want to. Well, the only thing that's going to change is that 4 needs to become a 12. Well, if I just start right now typing in 12, it's going to put a 1 over the 4, and it's going to put a 2 over the parenthesis, and the parenthesis will be gone. I don't want that to happen. I want to put the insert key. So hit second, insert, and you see how that cursor changed to an underscore, right? When you have an underscore, that means that the next key you push is going to insert that symbol in front of what is being highlighted right now. So when I push a 1, it's going to insert in front of the 4. Now I want that 4 to become a 2. So I just move back left and right to get my cursor to go from the underscore back to the block. Push 2 on top of there, and now I've got 12. But now I'm going to come down here, and instead of having to do 12 times 10 in my head or whatever, I can just redo that 4 as a 12 or a 124. Delete that 4. So now I've got 12 easily. So compounding it 12 times monthly earns me basically another $1.97. Okay. So $2. 8 more compounds only earns me $2 more. That makes sense? Now 8 more compounds per year. So that's 80. We compounded it 80 extra times there, right? And I only got $2 more from it. Okay. Let's think about this. Let's go weekly. So weekly, that 12 would change to a what? 52. Okay, so put that as a 5. Put that as a 5. Okay, so we're going to compound this thing, 400 extra times compared to what we just did, right? Compounding rolling my money over 400 additional times in 10 years gets me another, like what, 80 cents or something like that? Okay. No, it's $1 or something, isn't it? $1.30? I don't know. Do that math. Okay, subtract those and you see what the difference was. But it's not very much, right? What if we do it every single day? Okay. So every single day I'm going to put that as, instead of 52, it's going to be 365, right? Oops. And it makes me 20 more cents. Okay. So that's, what? So we did 365 minus 52 times 10. We did an extra 3,130 compounds, and it got me 20 more cents, right? Okay. But what you're seeing there is the more compounds does create a larger result, right? Okay. But eventually it starts to kind of plateau, okay? But you always get more. Now, it might not be a full, if I go out to, compound this thing 1,000 times a day, okay? I might see that I'm only maybe gaining, tenths of a penny, okay, or hundredths of a penny. But it will be more money. Does that make sense? Okay? The more compounds that you're able to obtain, the better it is for you as a consumer. Okay, so this is something that banks understand. This is obviously they're very interested in this stuff, and realize that a bank, though they do you a public service, they are businesses, right? And what do businesses need to do so that they can gain gain you as a customer? What do they need to do? What does any business do? What does Pepsi or Coke do to gain you to be a Coke or Pepsi drinker?
Invest confidence in the market. Create confidence in the consumer.
Okay, so but how do they do that? How do they get the regular old person that's sitting at home driving their car to say, that looks like a good thing for me to do?
If they're successful in their business.
Okay, but then if they're successful in their business, then they do what? They advertise. Okay? They show you somehow how they've been successful. Okay, so they do marketing, right? So banks will market this stuff. Okay, if you go to any bank's website, it will tell you kind of the first kind of thing you see on their website. They'll tell you today's interest rates and today's rates that they can provide you. Okay, it's a marketing tool. Okay, well let's do a comparison here. Let's say that let's deal with like a large bank. So Chase is a worldwide bank, right? Okay. Hope nobody from Chase watches my videos, but I hate Chase. I bank with them, but they're dirty. Okay. Superior, all right, is a credit union, right? Okay. They're more localized, correct? Okay. Now, so think about this. Chase is worldwide, so they probably have more resources than what Superior does, right? Okay. So Chase might be able to do things that maybe Superior can't do for us. Okay. I don't know if these dynamics and the way I'm explaining this is 100% right, but Chase, because they're larger, they might have more resources, they might have more power to compound their entire customer base more often than what Superior can do. Does that make sense? They might say, we have the resources that we can compound your money monthly. Okay? So let's say that Chase can do it monthly, and Superior, maybe they can only do it quarterly. Okay? So Chase is going to roll my money over at the end of every month. Superior is going to do it at the end of every 3 months. Okay? Let's say that Chase says, though we can do that, but we're so big that we can't give everybody a 3% interest rate. We can only give people maybe a 2.9% interest rate. Okay? But Superior says, well, we're a little bit smaller, and we feel that, customer loyalty is a huge thing in Northwest Ohio or whatever. We know we can be competitive, and we can actually give 3%. Okay? So let's say that you are a person, you're saying, okay, I've got a choice. And I'm going to base my choice simply off these two things. I've got $1,000 to invest. Where am I going to put it? Okay? So let's say that we put a principal of $1,000 in here and a principal of $1,000 in here, and we want to figure out which is the best bank to invest my money in. Okay? Now there should be other attributes, other things that you look at. Okay? Chase, and this is why I think Chase is dirty. Chase will they have stipulations on their savings accounts that if you don't have X amount of money in those saving accounts at a particular time of the year, they will deduct $50 from you because they say this account is an account that's supposed to have $15,000 in it all the time. And because you don't have that $15,000 in it, we're going to fine you. That is stupid. Take money away from me because I can't put $15,000 in there, and you keep taking my money from me. I can't put $15,000 in there. Okay, so they do that kind of stuff. And now a lot of times, so this happens to my wife a lot because she does the banking, and she'll call Chase once a year and just rip them and say, you're taking money out of my account for no reason. And then they'll say, oh, it's because you're in a certain type of tier or bracket. We'll put your money back in. We'll give you your money back, and hopefully you stay our customers. Okay, but not everybody does that, right? Okay, some people will say, well, I'll just pay the $50 and I can pay attention to it, or $20, whatever it is. They also have things where I can only make maybe 6 transactions in a month. Well, if I'm somebody that's buying a lot of crap, that's a problem, right? And they start finding you over certain, so that they do dirty things. Superior does that as well. They have I don't think it's a transaction thing, a limit, but it's it's a withdrawal or transfer limit that they have problems with, okay? And they fine you for those things. Because what they're saying is that it's taking our resources to transfer these money, it's taking our time, which a computer program's probably doing it, so they're lying to you. But they're saying it's costing us work, so we're going to fine you for that. It's dirty. It's my money. Let me have it. I'm going to put it in a coffee can in my backyard. So what we do is we just calculate these two things separately. A of T, $1,000, 1 plus my interest rate now of 0.029 divided by 12. Okay. Now, the only thing we got to pay attention to is the N times T. I didn't write an N on here, or sorry, a T on here. Just let it be constant. Let T be 1 for both. Or let it be 2 or 3 or whatever. You're still going to be able to figure out, as long as it's constant, you're going to see which one is best. Okay, so I'm going to let my T be a 1. So then we'll do the same thing over here, but now my interest rate is 3%. My compound is 4. So now I will take N times T to be 4. Okay? So the whole thing then is to see is if this 12 right here as an exponent will compensate for that value there being smaller than this value over here. Does that make sense? Okay? So we're basically seeing if the exponents are going to compensate for the other information that is lacking from account to account. So we're going to go 1,000 plus then times 1 plus 0.029 divided by 12, and then raise that to a 12th power. Hit enter. So at the end of year one, I've made $29.38 in this account. This is most likely not a savings account because savings account gets you like 12 cents back in a year. Okay? Their interest rates are very, 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 very small. If you've got money sitting around, this is my advice to you, my economic advice. If you've got money sitting around at some point in your life and you're not using it, you don't need it for anything, no rainy day or anything like that, invest it somewhere else instead of a savings account. Okay? Put it in stocks. They grow a lot faster. Put it in bonds. They don't grow as fast as stocks, but they still grow. They're not as risky as stocks. But invest it somewhere else other than a savings account, because you're in a savings account, you're basically just saving. You're not making any money off that. Now I'll do the same thing for the superior account. So this went to a 0.03, but my compounds went to 4. And hit enter, and I get I get 1,030 back, right? So I made almost $1 more in the superior account. Okay, but what Chase is seeing, and what people are recognizing, is if they see that compound at 12, Chase can use that 12 as kind of a marketing tool, right? We compound 12 times a year. Superior only compounds 4 times a year. That's what gets people to go to Chase. Because some people aren't going to do that math, right? Does Chase earn customers and make money doing it that way? Yeah, that's a marketing tool, right? Okay. They can lower their percentage, increase this, and that's going to gain some people. Okay. But if you're an informed and intelligent consumer, you're going to do the legwork prior, hopefully, to recognize which one is better. Okay. Even though they've got this flashy compound amount out there. It's eight more compounds than Superior. Superior is still the better deal. All right. And that interest rate, that's not a huge difference, right? Okay, but you still see that you get quite a bit more money with Superior. Okay, say quite a bit, but quite a bit's relative, right? If $1,000 gets me $30 back, okay, $100,000 is going to get me a lot more than that back, right? Okay, $1 million, you're going to get a lot more than that back than that. So those are things to kind of consider. Now here's where we start to build on this idea because we talk about compounds, and we've seen the example where we compounded 365 times, right? And that got us like 20 more cents than what we did if we did it 52 times. Let's say instead of compounding 365 times, we compound it twice a day. So we compound 700 sometimes. Maybe we compound it every hour, okay, of the year. Okay. Maybe we compound it every second of the year. Okay. Maybe every half second. Maybe every tenth of a second. Okay. Eventually, we're compounding to a point that once we finish compounding, we just start the process over again. So we compound kind of instantaneously. Does that make sense? So my money is continually rolling over, and I'm continually, every maybe cent that I earn starts to be added to a new principal, and it starts adding interest on the instant. Okay? So let's talk about how we can develop a formula for that. Okay? A long time ago, a guy named Euler, Leonhard Euler. Oh. Okay, that's how you spell his name. He was interested in looking at a function and the limit of a function. That was that. Okay, that was the function he was interested in. 1 plus 1 over x raised to the x. I'm not sure why he was interested in this, but he started, and this was a long time ago, so he had no technology like we have. But he was interested in a limit as x goes to infinity. Okay? And we've been dealing with, we haven't dealt at all and told you anything about what a limit is. But we have talked about what happens when x values get really, really, really big, right? In behavior, correct? When you see the word limit and infinity together, it's basically talking about a horizontal asymptote. Okay? So he wanted to know, what is the y value approaching as x got really, 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 really big here. Okay? And he found out that, let's see here if I can change this to a bigger number. Awesome. All right, he found out that when he graphed this function, okay, and started evaluating it at values of x that were very, very large, okay, you evaluate at 1 and I get x, my y value to be 2 there, okay. So then he evaluated at something very large, okay, we got 50,000 here, and I got 2.718. So if you look at this in the long run, okay, does it look like that y value right here is getting pretty close to, a little bit bigger than 2.5? Okay. If I start looking at this amount, this x value, the input value getting very, very large, you start to see that number, that 2.718 number, as I move this, is the 2.718 changing? And the 2.71828 kind of out to there. Everything after that is what's changing, right? And I keep increasing this, and we start to see that those numbers there, those are probably pretty constant, right? Okay. So these are changing right now. And then as the values of x get larger and larger and larger, maybe these points or these place values stay constant, and the ones after it are the only thing that's changing. And he started to recognize and realize that this function, as x gets to infinity, is approaching some number. But that number that it's approaching is a pretty ugly number. Okay? What kind of numbers do not repeat and do not end? Irrational. So he was coming up and he was seeing that this 1 plus 1 over x raised to x is approaching some irrational number. Just kind of show you real quick that this number does not repeat very well. This is a program called Maple. It's just a very high-powered calculator, basically. Highly priced, too. But let's say I want to evaluate, the exponent of 1. Okay, the way I type this is exp of 1 will give me e. But I want it to evaluate that. So let's just say I type this in. So we'll evaluate that last value to 10 digits. And there's, and I know from some of you in the back you can't maybe see it, but it says 2.71828281828. That's exactly what your calculator would give you, 10 digits. Okay. But if I do, instead of 10 digits, maybe I do 100,000 digits. Okay, and this is kind of the thing Euler was, I don't know if this is how many digits he went out. Really? Let's do this. Eval f exp of 1 to all right, so one thing to recognize there, that was pretty quick for as many numbers as it's going to give me, right? Okay. So 100,000 digits there. And you start to recognize that that thing does not repeat. Okay? There's no real pattern existing inside there. So logistically writing that number down, I think is a good visual, right? Writing that number down is not really feasible. Okay? I think I've read somewhere, I may be misstating, but like pi, the current digit that we currently have for pi would, you guys know the Harry Potter sequence of books, right? And how big those would be. All those books together, and that font, if you wrote one number for every basically letter in those books, that's kind of how far out we have pi currently. Okay? Which is ridiculous, right? And we're seeing so far that it does not repeat, it does not show any patterns. And that's what he was interested in. Okay, so he figured out this is an irrational number, so in the event of not being able to rewrite it, we know that 2.71828, whatever it is after that, we call it E. Okay? You guys know it to be the natural number, right? But why is it called E? Because his name's Euler! Zach? You create a number, Zach, and we'll call it Z. Or be 0, like you're great. All right, so that's why we call it E. That's why it's I always get questions. Why is it E or whatever? But because of it. All right. In science class, maybe you've heard it as Napier's constant. Anybody heard that? Physics? Maybe no.
We're not that smart.
So what happens is we should be able to come up with another equation that uses this idea. Okay, so let's go back to our A of t formula. My principal, 1 plus r over n raised to the nt. Now here's the thing. This thing kind of looks like this thing, doesn't it? Okay. Now they're not exact, but they kind of look alike. But what we want to do is, the idea is we want to compound continuously. So we want the idea that this thing here is going to infinity. This n is going to infinity, and so is this one. And we want to be able to kind of figure out, is there a formula that exists that would allow us this to happen? So I'm going to kind of play around with this a little bit algebraically to see if we can make any comparisons. Can I rewrite this as 1 plus, I'm going to write my r over n as 1 divided by n over r. If I write it that way, now it might not make sense on why we've got to do this, but we're just using some algebra tricks here to rewrite that set of parentheses. Because it's 1 divided by n over r. Is that still r over n? Yeah, just an alternative way of writing it, right? Okay. Now let me do this. Can I rewrite this exponent of n times t as r over n? Okay, now I'm going to put parentheses around that, or a bracket around that, and raise that to the n. Come on. So I'm sorry, not r over n. I'm sorry, wrote it backwards. N over r, and then times rt, or raised to the rt. Now let's think about this. Is for my highlighter. Is that exponent raised to that exponent? If I multiply those together, that's n r, or n over r, times rt. What's that reduced to? What's that cancel out to give me? NT, right? So is this okay? Is this thing right here, is this line that we just wrote exactly the same thing as that right there? Yeah, okay. But the reason we wrote it this way is because we're going to be interested in saying that this thing here, collectively, that thing that is green, does that look like this format right here? We got 1 plus 1 over x raised to the x. Well, down here, if I let n over r equal x, okay, and because r is a constant fixed rate, as x goes to infinity, so does n over r. Does that make sense? Okay, so this statement up here, we are able to know that that approaches e because of this variable x, right? Okay. Well, down here, this thing should also, that thing should also approach e because when n over r is the same thing as x. As x went to infinity, this thing went to e. Well, here, as this x goes to infinity, okay, n goes to infinity as well because r is a fixed number. So what we find out then is that that thing right there is simply just e when we have a lot of compounds. Does that make sense? So what happens then is that this formula becomes P, E, and then we have these exponents of R, T. You guys seen that formula before? Okay. A of T, we'll write it and clear things up here. You did that in 7th grade?
Yeah.
A of T is equal to principal E to the RT. Okay? And that is the compounded continuously formula. Okay? So if they use words like annual or semi-annual or weekly or biweekly, monthly, daily, hourly, those types of things, you have to use the P times 1 plus R over N raised to the NT. But if they say continuously, you use this one, where P is your principal again, E is the constant E, okay? And then R is your interest rate, and T is the number of years. Okay? I'm not going to do an example right now, you can run out of time, but it's the exact same procedure as what we did before. That's another thing that maybe banks can use. Maybe, as a marketing tool, they can say, we compound continuously, okay? But we can't maybe give you the same interest rate other people can give you. You might see this in this assignment. I'm not 100% sure. But if you see a question that says present value, okay, present value is another word for current principal, the amount of money you got to put in the account right now. Does that make sense? Okay. So when they're asking you present value, they're asking you to find capital P. And with that question there, you can plug in everything you know for your compound interest formula. Okay, the one that deals with quarterly, and you'll be able to fill everything in, and P will be the only variable you can solve for. So solve for P, and I'll tell you how much money you need to invest at that time, so that down the road in 8 years you can pull out $4,000. Okay, we'll talk about a couple of these tomorrow, but my hopes are to go maybe into the next section as well. Okay, so do a couple examples of these and move on. We will also, eventually, once we talk about logarithms, which is tomorrow's stuff, we'll come back and do more of these problems. Because once we learn logarithms, we can then solve for things like t and n that are up in the exponents. And those are a little bit more interesting type of questions.
Right.